Okay, welcome back to another video. This is Yao from VANTAGE TUTOR, a class above the rest. Well, it's been a while since I've done videos like this. I finally finished my relief teaching term and now I'm back to making TikTok videos. Okay, so this is a H2 Chem question from Jurong Junior College 2015, paper 2, question 4B. Now, if you'd like to try this question, you can either go online to look for the paper itself. Okay, I already told you which paper is from which year. Download it, have a try first, or you can simply just pause this video right now, have a look at the question, give it a try, and then you're gonna see how I'm gonna do this question in a while. Okay, let's get started. Now, most probably I'm just going to do part B on TikTok in the interest of time. Part C, I'll do it all together with part A and put it on YouTube. Okay, so if you're interested, you can go onto my YouTube channel and finish your question. Now, this is a typical synthesis question. Okay, so whenever I see a synthesis question, I always look at the functional group present. I can see that there is a carboxylic acid and there's an alcohol, and most importantly, there is an alkene group. Okay, now, the question asks, compound D, when added to PCl3, you get compound F. And then from compound F, you actually get compound G after adding your ammonia. So what do I do here? I look at PCl3. It's a compound that I'm very sensitive to, because whenever I see PCl3, I see my substitution, nucleophilic substitution, for a OH leaving group. Okay? So my compound is very simply, if I have to draw it out, it will be CH, so this will become Cl, double bond, CH, COCl. Okay, if not, if I draw the skeletal, I think it will look something like this, double bond, Cl, then double bond H, double bond O, Cl. Okay, so in this case, I happen to draw the cis isomer. Alright, next part, you actually add your NH3. So let me first give you the answer before I explain. So NH3, I know that I have a lone pair. I'm basically looking for a stable leaving group to do my nucleophilic substitution. And more importantly, if you're experienced enough, you'll be very sensitive to the fact that whenever you have a nitrogen compound with an acyl chloride, you are generally expecting to form an amide. So I'll get something like double bond, O, and this will be NH2, and then this will remain as my Cl. Okay, now I hear some of the uproar already. Okay, someone will probably be asking me, Mr. Chen, I thought you said that you're looking for a lone pair and then looking for a leaving group. You can see that there's a Cl over here, but why did it not react? Okay, now for first of all, whenever you talk about your lone pair NH3, you're looking to attack something that is electron deficient. So in your acyl chloride, your electron deficiency, or rather electron deficient carbon, is right here. Okay, due to the difference in electronegativity, there's a net dipole moment up going towards your oxygen. That's why your oxygen, or rather the carbon attached to the oxygen, gets attacked. But then, if you look at this Cl over here, okay, it's not going to get attacked. Why? Because you can see that there is a double bond. And in organic chemistry, we see that this double bond is actually very electron rich. And therefore, there is actually no nucleophilic attack. This is very electron rich region, it's not electron deficient, and therefore this lone pair on your end is likely to be repelled away from your double bond at your alkene group. Okay, now moving on. So let me just erase this, make it look a bit neater. So last part, compound E, you have H2 in the presence of PT. So you straight away know that this is reduction. Okay, so this one you can more or less memorize. Okay, H2PT can reduce almost anything except for your carboxylic acid. Okay, so because there's a carboxylic acid here, that group is likely to remain unchanged. So I have my C double bond OH over here, but then at the same time I have my alkene double bond, which I know will be reduced, so it becomes an alkane, and then my alcohol remains the same. My OH remains there, so basically I'm just adding a H here and a H here. Okay, I know the question asks for structural formulae, but you know, for me, I'm more of a skeletal guy. When you do organic chem long enough, you actually prefer skeletal because you can actually see how the molecule is orientated. Okay, now so this is the end of the question for the TikTok part, which is 4B. For 4C is a bit of inorganic chem, a bit of like guessing to get your answer. Okay, so if you'd like to know the rest of the question, or rather the answer to the rest of the question, please proceed on to my YouTube. If not, this question, my main concern or my main thing that I want to go through is my compound G, where a lot of students will ask me why the Cl is not substituted. Okay, because they are thinking that it's a halogenated alkane or halogenated derivative. Alright, so this is Yaula from VANTAGE Tutor. The class above the rest. Take care. Okay, welcome back to the second part of the video, which is doing Jurong Junior College 2015 Paper 2 Question 4, but Part C. Again, if you'd like to try this question, please go online and search for this paper. I believe you can find it on Reddit. Download it, finish the question, then come back to watching this video. Alternatively, you can pause the video right now, try this question, and then when you're ready, just resume the video. You can see me going through the question. Alright, so if I look at Part C, this is a question that you tend to see a lot in your prelim papers. They don't. So let's go through first. Compound D reacts with sodium bromide in the presence of concentrated sulfuric acid to form compound H. So compound H is not drawn here at all, but basically you start from compound D. Okay, and then somehow you react and then you actually form this compound right here. So my main concern is, what is the difference between the molecular formula? So firstly, I'll count the number of carbon with C1, 2, 3. Okay, H, how many? 1, 2, 3, 4. O, I got 3. Okay, so firstly, if I compare the difference in the chemical formula, you should realize that the difference between compound H and my compound D is just HBr. Okay, let me just write that better for you. HBr. One H is missing, or rather one H is added, one Br is added, and therefore I can more or less suspect that this is going to be my alkene and its electrophilic addition. Okay, now C part 1, the reaction occurs in two stages. The first between inorganic reagents, the second involving compound D. That means stage 2 is most probably my electrophilic addition. But stage 1 is something that I don't know, okay, because it's inorganic reagents, okay. So now I know that I'm trying to generate my HBr, so I kind of have to wing it. What do I mean? Let's try it. So now I take my NABr. Okay, maybe I should use this instead. Yes, okay, so NABr plus H2SO4. Okay, so what I should get is HBr. This one is for sure. I need a HBr because of what we talked about just now. So now it's just about balancing the equation. Okay, so if I take out one Br and one H from the H2SO4, the remaining should react, and therefore my compound should be NaHSO4. Okay, you have to guess. I don't know this reaction as well. Maybe it's in the notes. I don't know, but I don't think it is. Okay, so that's the end of stage 1. Stage 2 is just simply showing me your electrophilic addition. Very easy. So they say they want the structural formula, so I have to draw out nicely. So this should be CHOH double bond CHCOOH plus HBr, and because it's electrophilic addition, okay, I can just add it to my double bond right here. So what's gonna happen is you can draw either way of adding it. That means either the H on the left and Br on the right, or you swap it around. Doesn't matter. They didn't ask for major or minor product. Neither can you justify. Neither do you need to justify. So it's just CH. Okay. Now instead of CH itself, just CH2. Then bracket OH. Then this will be CH BR COOH. Okay, and that's the end of part C, part 1. Okay, now moving on to the next part. When concentrated sulfuric acid is added in this reaction, cooling is necessary. If the temperature is not controlled, an inorganic compound is formed. Inorganic compound. So what does it mean by inorganic compound? That means there is no carbon involved. Okay, so but this inorganic compound can also react with compound D, which may be produced. Now, this question basically given you something to do with your Br. So you know that electrophilic addition, whenever we talk about addition, we can add a lot of different things. H2O, HBr, even H2, your reduction and whatnot. So in this case, I know that you're trying to add something that's got to do with your Br again. And if you read from your notes, you recall that your electrophilic addition, the two most common so-called addition is actually your HBr and your Br2. So most probably, combined with the fact that there is an inorganic byproduct, I will suspect that the byproduct is actually Br2, because there's no other compound that is related to your electrophilic addition and also at the same time to this NaBr. HBr, first part, and therefore second part, most probably is Br2. Okay, so give the identity of this inorganic byproduct, write equation to show how it is formed. So this inorganic byproduct, I would think, is Br2. Okay, the state symbol is not important. So now it's about trying to balance the equation. Show me how a side product is formed. So cooling is necessary. So firstly, if it's not controlled, an inorganic byproduct is formed. So I would suspect what they're trying to say is after forming a HBr, due to temperature, it can further react further. Okay, so if I add this to H2SO4, okay, I'm expecting Br2. Then now it's about balancing the equation. Now if I take out one Br from the HBr, I'll left one H. Then I got H2SO4. I suspect there's most probably a H2O. Okay, but now that you have water, what do you do about the sulfur? So I have to make a guess lah and try my luck lah. So I'm guessing, I don't think it's sulfur trioxide because it's not very common to form sulfur trioxide, and therefore I'm gonna guess SO2. Now I need to try to balance. Okay, because there's a Br2 here, this must be 2. Then SO2, there's 2 excess oxygen, and you got 4 hydrogen. So this must have been 2H2O. Okay? And that's more or less my answer. Okay, you can go on and check the answer and let me know whether you agree with it. But questions like this, you more or less have to so-called wing it and infer. And in this video, I'm just trying to show you how to actually wing it and make a reasonable guess by linking up the different ideas together. Okay, so thank you for watching this video. I forgot to mention on my TikTok, the shorter version, that I'm trying to achieve 1,000 followers or 1,000 subscribers such that I can do a TikTok live, where during a TikTok live I actually do questions from various papers, or you can send me questions that you don't know, and I'm essentially going to lead you through my thought process as to how to solve the question. Okay, getting the answer is not a big deal. You can always go online, look for the work solution, suggest the answer, and you always will have the answer. However, what distinguishes you from the other students is that you must be able to understand how the answer comes about, and you must be able to justify the answer. If you cannot justify the answer, you don't understand the concept at hand at all. Okay, so again, if you enjoy what I'm doing, give me a like on this video, subscribe. If not, follow me on TikTok. I'll be doing more of these videos. If nothing else, this is Yao Le from VANTAGE Tutor, a class above the rest. Take care.